So, who are you? Famous question.
My name is Jesse Kaplan. I'm a program manager for the Common Language Runtime, the CLR, and I work on compatibility and ComInterop. And this is my office mate, Fernando. He's one of our security testers.
Oh, wow.
So, I wanted to talk to you guys just a little bit about compatibility in the .NET Framework 2.0 compared to previous versions, and then just compatibility in general.
Okay.
And some of the principles and technologies.
So, are we talking about like side-by-side running of apps, or are we?
So there's three basic types of compatibility we're talking about. There's side-by-side, which is the ability to run your app on the framework it was built against rather than previous versions or future versions. There's backwards compatibility, which is the ability for an application to actually work when it runs on a future version of the framework.
Yeah.
The names are a bit odd, but I'll... There's also forwards compatibility, which is applications built on, say, version 2.0 run correctly on version 1.0.
Yeah, those always get me switched around because forwards is actually backwards and backwards is actually forward.
In my interview here, they talked about that, and I spent about 10 minutes on it, and they were okay that the first 5 minutes was just trying to reconcile backwards and forwards compatibility, so don't worry about that. So, for side-by-side compatibility, it's fully supported in .NET Framework 2.0, and will be in the future. There are some cases where you can't rely on side-by-side, where you actually do need to run on the latest framework. And I'll get into these later. I want to talk a little bit about that.
Cool. Backwards
compatibility is also fully supported. We test extensively, and we'll get into details on that, making sure that 1.0 and 1.1 applications work great on the new framework.
Yeah.
Forwards compatibility was supported between 1.1 and 1.0 because it was only a small release, and it was likely that a 1.1 app could use 1.0 only features. But we've added so much in 2.0 that it's unlikely you could write a 2.0 app that works in those versions.
Yeah.
So for this version, we don't support going backwards. That way you know exactly how your app's going to work and how it's not going to work.
Yep.
So, like I said, a big point of compatibility is side-by-side and when you can use it and when you can't. So, just to allay concerns for most applications and tell you a little bit more about it, I'd like to use the whiteboard.
Sure.
Actually, if I could.
Oh, that'd be fun.
So,
actually, let me get on the other side because the lighting's like
okay.
Great.
When we talk about compatibility and we talk about applications, there's mainly three types of applications we look at.
Okay.
There's managed exes.
Yep.
And these are just your standard WinForms app, your console app, maybe a Windows Service exe that runs on its own. And these are just pure C#, pure VB type of apps.
Okay.
Then there are applications in a configured host. Now, when I talk about this, I'm talking about an ASP.NET application, or maybe a SQL CLR application. And these are applications that run inside another host, but that host knows all about the .NET framework, and it knows how different apps want different versions of the framework. So those are generally very stable about which runtime choices they have. And then the other is an add-in to a native application. So the typical example here is an add-in to Office or Internet Explorer. And you typically write these in a managed component that you expose through ComInterop. And these have a different runtime binding choices than the others. But let's start from the beginning. So managed exes encode inside the exe what version of the framework they were built against. So if that version of the framework is on the machine, it's going to get that version of the framework. So it doesn't matter what we did in the next version or previous versions, your app's just going to work.
Right. Now what happens if I try to run a 1.1 app on a machine that only has the 2.0 runtimes loaded on it?
So in those cases, we need to talk about backwards compatibility and the ability of the 2.0 framework to run 1.1 applications. And like I said before, that's fully supported. What's going to happen is it's just going to run on 2.0.
Okay.
So applications work best in what they were built against because that's what you guys tested it on. But we do a lot of testing to make sure they run on 2.0, so if that's the only thing available, it'll take that.
Oh, that's really interesting.
Yeah.
Okay.
So in configured hosts, it's a little different. So this is basically ASP.NET / SQL CLR. So if you write an application that's part of ASP.NET or it's a SQL CLR app, it's going to run in a host that knows a whole lot about the framework. ASP.NET and SQL CLR are both tightly integrated with the frameworks, and they know which apps use which frameworks. And in SQL CLR, you only ever get one version of the framework because it's super, super important that everything runs exactly as expected, because you don't want framework versions like tiny bugs or something corrupting your database. So you always get exactly what you're configured for. So it doesn't matter what else is on the machine. If SQL CLR is there, the framework you were built against is there, and that's what you run on.
Okay.
For ASP.NET, we offer a lot more flexibility, and you can actually go into the IIS configuration and choose which apps go on what frameworks.
Now, as a developer, do I have to do anything to my code to make it aware of the different runtimes, or
For ASP.NET?
for either managed or for any of these three scenarios?
For these two, for managed XEs and add-ins to configured hosts,
Yeah.
you don't have to do anything. It's either encoded in the app or it's done by default when you register it for IIS
Okay.
or for SQL CLR. We'll get a little bit into add-ins to native applications in a bit. But for these two, all the information needed is available.
Right.
And you get the best version for your app that's on the machine.
Now, if there isn't a runtime available, does the behavior change at all
If
running
there's-
1.1 or 2.0 apps?
What do you mean? If there's no runtime?
Yeah.
If the 2.0 runtime's not installed, or if no runtime's installed, 1.1 and 2.0 apps are going to behave exactly the same.
Okay.
You're basically just going to get an error saying install the .NET framework.
Okay.
So
And if you run a 2.0 app on a machine that has the 1.1 framework,
that's
will it-
forwards compatibility.
Yeah.
And we talked earlier and said we can't really do that anymore. So what's going to happen is you're going to get a dialog saying, hey, go to Microsoft and download this version of the framework.
Okay.
So it'll tell you what version you need and all that.
Very cool. Why don't we just put all the frameworks on all the machines? That's a common question. I'm sure.
Well, your machine, you already have a computer, and we haven't shipped the .NET Framework 2.0, so
Yeah.
it's not there. New versions of OS include previous framework versions. Windows Server came out. SP1, Windows Server SP1 includes the .NET Framework SP1. So it includes the latest CLR available at the time. And Windows Server R2 is going to be released, and that's going to include 1.1 and 2.0.
Interesting.
And then in Longhorn, you'll have 2.0 as well. And,
Yeah.
of course, the ability to install previous versions. But you'll at least get the latest and greatest at the time.
Very cool. Thanks.
So, the third category of applications is add-ins to native apps.
Okay.
And this is really the only place where we see any problems as far as compatibility is concerned. This is the only time the app's ever running against a framework other than what it expected.
Right.
Because in a COM case, if you're loaded via COM, we have to assume that the native app doesn't know anything about managed.
So a good example of this is like NewsGator that I use to read RSS feeds, right?
Yeah. So that's loaded inside of Office, and because we don't know what apps will be loaded inside of Office, we don't know which ones you'll install while it's running, we don't know what Word docs you might open that include the framework as part of them. So we have to choose the latest on the machine because that's the one that can run all previous versions.
Okay.
So for the best example here, actually, the one that really drives the point home for us, is Internet Explorer.
Okay.
You can embed a .NET Framework control in Internet Explorer. So you can have your web page, and you can have your little .NET control. Now, if we looked at the first .NET control that was loaded inside of IE and loaded the corresponding framework, which we could do, what you'd get is, if it's a 1.1 control, you'll get the 1.1 .NET-FX.
Okay.
And if you then navigated to a web page that had a 2.0 control, you just transfer over there. That's no longer going to load. Whereas if you had loaded the 2.0 framework in the first place, both pages would have worked.
Right.
So we don't want the order a person visits a web page determining which apps work and which don't.
Sorry about this. I'm just going to extend my tripod down a little bit.
Okay. So for this reason, when your managed code is loaded in a native process via COM,
Yep.
and no information about which runtime choice is made inside the native app, we're just going to have to choose the latest because we have to assume the native app doesn't know what's going to be loaded, and any framework installed on the machine could have apps corresponding to it. So we'll just pick the latest to make sure that all apps work.
Okay.
But that does mean that if there was something in the 2.0 framework that broke the 1.1 control, that 1.1 control is not going to function properly.
Okay.
And so we'll talk a little bit more about breaking changes and when they're acceptable and when they're not, and why sometimes we have to make them.
Right.
And about how to test to make sure that you aren't impacted by those.
Now, will a user who's, maybe mom and dad, who maybe not technical like me and you are, will they get an error that makes sense, or in this case, or
If there's an incompatibility?
yeah?
Probably not.
Uh-oh.
Well, when a native
So
application...
mom will call me, hey, this thing doesn't work.
When a normal app
Yeah.
crashes, mom and dad can't do anything about it. In fact, you and I probably can't do anything about it when Word crashes, except for the fact that we call up the guy who wrote it.
Yeah.
So you basically need to contact your vendor if you find that one of your applications breaks.
Okay.
And just because an application break doesn't mean it was because of the framework. It could be other reasons as well.
Okay.
And so I want to talk to you a little bit about backwards compatibility.
Yeah.
Forwards compatibility, you can't do it anymore in 2.0 just because we added too much.
Right.
A 2.0 app is just not going to run on the 1.1 framework.
Right.
So the other way around is the much more interesting case, especially when you talk about add-ins to native apps.
Now, why do they call it backwards and forwards?
I don't know. I think because we always had backwards compatibility, and there was never any platforms before that supported this notion of forwards compatibility.
Yeah.
Your VB6 app did not run on the VB4 runtime.
No.
So we did that, and we used the classic backwards compat term for everybody else. And then we added forwards. We added this new type of compatibility where new versions run on older. We didn't have a name for it. So.
Yeah.
It's the opposite of backwards compatibility, but
It's very confusing.
It's pretty counterintuitive.
Okay.
We actually have docs that went live on MSDN pretty recently that go into detail about compatibility and breaking changes and side-by-side
Yeah.
and what apps get what frameworks. So if you go to MSDN, you can find a lot of details on that.
Okay. Now, since we're talking about forwards compatibility, if I open up my application in Visual Studio, will Visual Studio warn me that there's some stuff that won't work in
Previous versions?
previous versions? Yeah.
No.
No. Okay.
Because especially in .NET Framework 2.0,
Yeah.
whatever comes out of Visual Studio 2005
Yeah.
is not going to be loadable by the .NET Framework 1.1 anyways.
Okay.
We actually changed the metadata version. So the metadata inside a managed app has a version number. And we changed that version number to make sure that it's not going to probably fail. It'll just not load, and it'll tell you you need to download the .NET Framework. That gives people really predictable user experience rather than the app hobbling along until it runs into a not supported feature.
Right.
So we're all about predictability and make it easy for the end user. Because the end user is not going to know what to do if it tries to use a feature that's not there. But if you get a dialog that says download this framework, you can do something about that.
Okay. And so what did developers need to know about this, about compatibility?
So the most important thing to talk about is breaking changes. Other than side-by-side and understanding what framework your app runs against, it's actual breaking changes. So whenever we create new features, whenever we do DCRs, which is design change requests, and when we fix a lot of bugs, there's a field that you have to fill out.
Hold on a second, since your roommate's on that.
Okay.
All right, we're back. We give your roommates
Just a few minutes, yeah. Got to talk to as well. Now let's continue.
So where were we? We were talking about what developers need to
So
know.
we're talking about breaking changes.
Yeah.
So whenever we do new features, whenever we do design changes to current features, whenever we fix certain types of bugs, there's a field the developer has to fill out, or the program manager, that says whether or not this is a breaking change. And when we say breaking change, we mean this is a change in behavior of a previously existing code that could possibly impact an application when it moves forward to the new version.
Okay.
When you look online and you see, for example, the Windows SP2 breaking change list, what you're seeing is 50 things that actually broke applications. And we're talking about things that just could potentially break applications. In fact, if you look at our list, we posted it online a couple days ago, there's about 200 things on that list. But in all of our testing, we found that fewer of 10 of them actually impact an application. And when we talk about impacting an application, it's not even impacting an application in side-by-side. So if the framework the app was built against is there, the app's still going to run great. This is an application on a 2.0 only machine has hit this. So there are fewer of 10 of those that if you configure the app to run on the framework, other than what it was built against, it fails.
Now, as a developer on the CLR team, why do you break change? What is the reason that
Right.
you would make an API not work in the new version?
So even when you go into breaking changes, there's several different categories.
Yeah.
There's design time changes. So if you open your old project in the new Visual Studio, it doesn't work quite right. And some of those, one of which we'll talk about later, is we added a new overload to a method. So you pass something that automatically got casted to, say, a double or a float, and now we have a double and a float version of that API. So you'll get an error saying, hey, this is ambiguous, please clarify. And there's things like that. Those are generally less impactful because it only hits the developer when they're trying to move forward.
Okay.
Then there's runtime breaking changes. And runtime breaking changes can be broken into two categories. One is an API change, where we actually change the parameters of an existing API. And I think we've done that once, and only for security reasons. And we still haven't found any apps that have been impacted by that one because it's an extreme corner API.
Okay.
So those are extremely rare. But you'll notice them very fast, which is one of the reasons why we haven't made them, because we have great tools that can immediately detect when we've changed that and we can revert it. So in case a developer accidentally changes an API, we'll know about it and be able to revert the change.
Yeah. My guess is on your team, you guys don't do this stuff accidentally, right?
Well, anyone can make a typo.
Okay.
I mean, when we consider API breaking changes, we consider even the names of parameters changing as an API breaking change. Because if you're using VB and doing laid bound, it can break you that
But
way.
on your team, you guys argue this stuff out. You know, it's always done explicitly with forethought.
Oh, yeah. So we actually...
It's not done by some developer accidentally just, sitting down one weekend
there
and
are
changing.
always bugs.
Yeah.
Which is why we have betas and why we're doing a lot of testing, which we'll get into later. But for breaking changes, there's a huge process that you have to go through if you want to make it a breaking change. So before I get into that, let me talk about behavioral breaking changes. Then I'll talk about how a developer would go about implementing a behavioral breaking change.
Okay.
So these are changes to the underlying behavior of an API or the framework itself. So the API looks exactly the same. You can still bind to it. You can still call it. But what it does is slightly different. Or you didn't make any API calls, just how the framework sets up the process, for example. So there's a tier of things that we consider when we decide what's an approvable breaking change and what's not. So the guidelines we have in mind, security is a good one. We don't like making it, and we try and make the break as minimal as possible. But we're going to break you guys for security if we have to. The next in the list is something that we always get asked to do, actually. It's a most common feature request. It's also a breaking change, is standards compliance. So for example, the ASP.NET team made a change in .NET Framework 2.0 to be compliant with the latest XHTML standards. But because they weren't before, it's a breaking change. So we've made a switch that really easily lets someone opt out of that breaking change. So we've made the change. It'll break a significant portion of ASP.NET apps if they're configured to run on 2.0. So if you explicitly configure it to move forward, you can be impacted by it. But it's really easy to change your web.config in about 30 seconds and revert the change back.
Okay.
And that's detailed in our breaking change list on an ASP.NET, so it'll be really easy for you guys to do.
Okay.
So standards compliance is one of them. Sometimes it's correctness. This is pretty rare, but sometimes we do it. So for example, we had a bug in our product. It was just a horrible bug. There were maybe really hard workarounds that someone could do, but when we fixed those bugs, we disabled those workarounds. So this is just making the API usable for most people.
Yep.
And whenever we run into this type of thing, we usually try and figure out a really easy way to get people back to the behavior that they were expecting before.
Okay.
And I think the most impactful breaking change that we make, is also most helpful to developers, is getting rid of non-determinism in our product.
What does that mean?
So this is behavior that just happens. You do something to your code, you set this variable here, you set this variable here, you drop this file in this folder, and you coerce the framework into doing something that you couldn't get it to do otherwise. I saw one blog post by somebody that said, I'm not sure how I got this working, but I think it had something to do with the color of my boxers and the value of the Japanese yen. But if I do this, I can get the framework to do this one thing. That's generally a bad sign. If you have to go through all those steps, change your underwear, to get the right behavior out of the framework, you're probably stepping outside the bounds of what we intended to support.
Yeah.
So a lot of cases where we change the random behavior to be very deterministic and easily modifiable at the same time. So for example, whether or not a thread starts up as an MTA or STA thread as far as COM is concerned. It used to be non-deterministic, whether you could set it at runtime, or while the thread was going, you could modify its state. You sometimes were able to, you sometimes weren't.
Right. MTA is
Multi-threaded department or single-threaded
Got it.
department. It's only interesting if you're a
I'm a
guy.
stupid guy. So.
That's okay.
I'm sticking up for the VB, for the beginning programmers out there who are trying to learn all the...
Sometimes you could do it mid-thread.
Yeah.
Sometimes you couldn't. Those sometimes behaviors changed. It's a different conditions in the 2.0 framework, just because we're built slightly differently. Mm-hmm. So rather than leaving in that non-determinism or unpredictable behavior, we made it very predictable and then gave you a really easy way to do it.
Okay.
And again, for that one, we added back a config switch, so that you can configure your application to get the old behavior.
And your white papers explain
the white
all
papers
this.
go into the details of all this and go into lots of other breaking changes.
Very cool. We'll link to those from the video.
Yeah.
So. Anything else we need to know?
The process for breaking changes.
Yeah.
So you can't actually just check in a breaking change. You have to.
So you're talking about on your team?
I'm talking about. No, I'm talking about the
entire.
entire .NET framework.
Okay.
We have a unified process on all this that you have to go through, and it's for the CLR team, it's for ASP.NET, it's for WinForms, it's for C#. And the first step is just the individual feature unit team says, you know what, this is something we probably should do. This is good for our customers, and why. And then they have to fill out a template that says, this is why we think we should do it. This is how it could impact customers. This is what the actual change is, and this is what the customers will have to do to work around it.
Right.
So there's a lot of details you have to go into. And then from there it goes higher in the product unit team, so maybe the com-interop team decides to make a change, and then that goes to the CLR team. And the CLR team management has to sign off on it. And then it goes to a unified group that oversees all breaking changes in the entire .NET framework and Visual Studio.
Yeah.
It's called DevDiv Compatibility Council. And those three wizened ones go over each and every change and approve or reject them.
All right.
And if we ever see an application that was actually impacted by one of these changes, which has only happened a couple times, they review it again. And sometimes they'll say, you know what, that really is the right thing to do, we have to do that. And oftentimes they'll say, you know what, a customer is impacted by this, you have to go back to the old behavior.
So are guys like Chris Brown reviewing all that stuff? Or?
Chris Broom's not Jeff Cooperstein, if anyone's heard of him. He's our lead security guru. He reviews it from the CLR point of view, and there are people from different point of views, from different teams in the .NET framework and Visual Studio.
Okay.
So Chris Broom definitely looks at all the interop ones, I'll tell you that.
Yeah.
The MTST one went right through him.
Yeah.
So that's all I'd like to say right now. You can go to our documents for a lot more. I'd like to introduce you guys to Sharupa, who's going to go over the different types of testing that we do internally and that you guys can do.
Okay.
And she's conveniently right around the corner,
Let's
let's go take a walk.
All right.
We have our compatibility boulevard here. We have all the compat testers and the compat PMs right in the same area of the building. It's very nice.
Hey.
So this is Sharupa.
Yeah, hi there. Let me get your name there. So I know how to spell it. I learned that little trick after making a few mistakes. So you're testing all the compatibility changes,
So
right?
no, I'm actually a PM on the compat team also.
Okay.
So I work with Jesse and with the compat test team.
Okay.
And so we basically, I wanted to talk a little bit about how we do compatibility testing
All right.
and the different scenarios that we run with. So I
And,
think Jesse.
who's this sitting here, by the way?
So that's my office mate. Do you want to introduce yourself?
Oh, sure.
I'm Diana.
And-
I'm a tester on a loader team.
Wow. So on the loader team. Okay. Very cool.
So I think Jesse just talked about like side by side and versioning a little bit. So one of the things that we test for is you have like both versions of the framework on your machine. So that's the side-by-side configuration.
Right.
And then we take your application that was built against like .NET Framework either 1.0 or 1.1 and we try and make sure that it installs correctly.
Okay.
So that's the first scenario that we test for. So sometimes installers actually have managed code in them, so just the presence of .NET Framework 2.0 might cause the installer to not work correctly. So this scenario kind of tries to identify those issues. The second thing we do is just the step after this, which is like runs correctly on this. So once your application installs on the side-by-side machine, we want to make sure that it actually runs correctly on a machine that has the new framework installed. Now, the interesting thing to note is if you have a .NET 1.1 app, it's actually running against .NET 1.1 if it's a managed XE. However, there are these situations where you might have an add-in that was built with 1.1, and just the presence of 2.0 on the machine makes the add-in roll forward and run against the new framework. So there might be some issues that you actually find through this testing. And the third thing that we do is basically run against. So for every managed XE, we make sure that now instead of running against 1.1, we have some registry settings that we can change, and we make all of the applications now run against the new framework. So that's actually the scenario where we expect to find the maximum number of compat issues, and yeah, that's where we find most of them.
How can you test a third-party app? Because you don't have the source code, right? You don't know what that app's supposed to do. So how are you making sure it actually
works? So we actually don't use source code for any of this testing. What we do is we do some baseline testing. So we take the app, just the binaries, and run it against .NET 1.1, and then we look at the behavior, and then we run it against 2.0, and we check to make sure that the behavior is still indeed the same.
Okay.
So yeah, we don't really need source code to do any of this testing.
Got it.
So that's running against 2.0, and the fourth thing that we test for is install on a 2.0 only machine. So like Longhorn boxes are only going to have like .NET Framework 2.0 on the machine, and we want to make sure that all your old apps actually install correctly on a machine that does not have .NET Framework 1.1 or 1.0 installed. Okay. So that's the fourth.
On Longhorn, you can still load the
Absolutely. You can definitely go ahead. So that's the only one that's installed by default. You can certainly go ahead and download and install 1.1 also.
And how many apps do you have to test?
Right now, we have a large number of apps. So we used to have 87 before. We're up to like 200 apps now.
Okay.
So, and we have teams all over the division that do compat testing.
Wow.
So on the CLR team, we have like 45 apps now, Jesse?
Something like that.
Yeah, so a lot of apps. I'm sure you'll soon meet the person who does a good portion of that testing. And what we also do is we test all of these scenarios on like 64-bit machines also. So the way it works for 64-bit machines is if you had an application that you built against a previous version of the framework, it actually runs in the WoW in the 32-bit mode. So the behavior is almost identical. Okay. So we do all of these 4 scenarios for 64-bit machines also.
Wow. Anything else we should know about the world of testing?
That's more or less all about the testing scenarios.
Yeah.
I also wanted to briefly mention that we're doing a bunch of compat dev labs, and we have one that we're doing in the first week of June. We're doing one later in June and one in July also. Yeah. And we would love for people to send us email, get in touch with us. We can send them the invites. We would love to have them down in Redmond where we do compat testing.
That's a good question. How if I was a third-party developer, how can I give you my app so that I know that you're testing it?
So there is an email alias that we monitor closely. It's netfxcmp at Microsoft.
Okay. So you're going to get 3,000 new apps to test.
We got this alias on eWeek.
Yeah, and we're getting
we got about
so
500
many.
this morning. So.
Yeah.
So there were so many. So if you send us email, we can. So there are all these different things we can do for you. We can send you a kit so that you can test your app on your own and report results to us. Okay. We have a survey for that. You can also send us your application. We can test it in-house. That's the other option. And the third option is you can actually come to our dev lab where we spend like 4 days of the week, and we get like developers, testers, program managers. Everybody's there to help and do like hands-on testing.
And also help with problems that you guys find.
Oh,
right?
absolutely. Yeah. Great.
Any other suggestions you have for all the .NET developers out there who are entering into this new 2.0 world?
So some of the suggestions are, so we try our best to make sure that everything runs fine when we release a new product, but sometimes we have to make some breaking changes. I think Jesse talked about them a little bit. So sometimes people end up relying on internal data structures, for instance. It becomes really hard for us to make sure those apps continue to work. So I think one recommendation would be please don't rely on undocumented practices, because it becomes so much harder for us to make sure that your apps continue to work. Yeah. So one good thing about submitting your apps...
How do you know, by the way, when you're doing an undocumented procedure?
So the documents should be all up on MSDN.
You go to Google and you don't find any information? Is that then you know you're swimming in the rough water.
So there are a few things, for example. We found a few applications that broke when running on the .NET Frameworks 2.0, not because we changed any behavior, but because we changed a private field. And we tried to figure out what was going on, and then we realized they were using reflection to go to a private field that's an internal data structure and change the bits. We use that field for something different now that's not part of our APIs. It's something that we can do. The API behaviors behave exactly the same. But if you expected that private field to do something else, it's not going to work. We found some people that, under poor guidance from people on our team, went to the 39th byte after a certain structure. I'm not going to tell you which because I don't want you doing it. And modified that and just assumed that it would always work that way. Well, we lay out memory a little differently because it's a managed application. You typically won't run into that type of problem. You have to really know what you're going after, and you have to be really relying on private data fields. So that's, if we find out your application is broken by that, we'll do our best to keep you working. But we actually have to have your application to know that that's behavior we need to maintain. So that's why all this testing is so important. Or that's one of the reasons why all this testing is so important.
Very cool.
Yeah, like some of them I think are pretty clear cut. Like if you're depending on the order in which your GC finalizers are being run, for instance, that's certainly, we make sure, we tell people that it's not going to be in the same order all the time, so you shouldn't probably be taking dependencies on that. So one of the cool things is if you actually send us our app, we'll continue doing app compat testing on these applications even as we release future versions of our product. So we'll try our best and make sure that that these apps continue to work on all future releases, not just for Whitby. So
because there will be a 3.0 at some point.
Exactly, there's going to be a 3.0, and we'll try and make sure that it works on 3.0 also.
Very cool. Thank you very much for spending some time with us. Thanks.
So if you'd like, we can go meet Rob, who actually does these scenarios on most of our applications, or at least a good portion of the CLR ones.
Sounds good.
He also helps with a lot of the investigations once we find a problem, and helps route it to the appropriate team. And here he is.
Great.
It's Robert.
Hey, how are you? Your name's easy to remember. I'm Robert too. So.
The problem is there's nothing on the door.
Yeah,
I just want to fix that, but it's been a couple months now, and they haven't.
And so, all right. And so, what do you do?
Hey, so I'm an SDET here on the Common Language Runtime team. Basically, I'm responsible for app compat testing. A couple different things in compat testing. First, actual testing of third-party apps that we get in from different customers. Another big thing I'm part of is basically helping to develop tools that detect breaking changes at the API level between runtime versions. So I'm supposed to give you guys some demos here today.
Oh, sure. I love demos.
Sort of areas where people have sort of fallen off the correct path.
Okay.
And have thus broken themselves. So let's
see. Could we stop just a second and get your refresh rate going? All right, we're back on air. Just had to switch your refresh rate, otherwise everybody would be getting a headache there.
Okay, so here we have a little demo. It's just a simple app, and it's called check4mscorelib.dll. So somebody has gone and they've used some method to get the framework directory. It's a common method that some people are actually using. And we're going to hit go and see what happens. Okay, it's found mscorelib in the version directory. Do you know what the version directory is?
No.
So the version directory is actually the directory where the framework gets installed to. So by default, it's under Windows, Microsoft.NET Framework, and this is the Everett version directory, 11.4322.
Okay.
So we're going to take the exact same app, and I happen to have my handy-dandy machine set up already.
Hold on a second.
Just a second.
Yep.
I'm hitting the table with my tripod. Sorry about that.
So over on this machine, we only have Whitby installed.
Okay.
So you know I'm not lying. Everett's not there.
You are a darn fast typist.
And here we have the Whitby assemblies. Wow. So it's the exact same app.
That's what it takes to work on the CLR team, folks. You better be able to type fast.
So, exact same app, and okay, so first thing is that it looks kind of funny, but that's a completely separate issue that I have to take up with the WinForms team. As you see, the go sign is cut off on the button. But anyway, I hit go, and uh-oh, the exact same map, it's saying something's broken, couldn't find MS Core Lib.
Right.
So what has this person who has written this application done wrong is something that we obviously don't recommend doing, but let's go take a look at the code now and see why this is behaving differently on Widby.
Okay. Opening up Visual Studio here.
So opening VS, my machine's a bit slow. Okay, it's excruciatingly slow, but...
Put in a purchase request for more RAM.
Okay.
Help us with that. Improve your demos.
So slow. Oh, you know why? It's because ITG is forcing me to install something at the moment. Okay.
As a Microsoft employee.
So let's see what they're doing here. So this is something that a lot of people tend to do, especially in their install programs. So what they want to do is detect basically the framework directory where they can find mscorelib.dll and other framework assemblies. So if you look here, what they first do is they go, okay, let's go get that special folder called system. So that's the system Windows system directory. And then they do things like, okay, get that as a string, and what we're going to do is cut off the /Windows system. So what we're going to do is cut off the system32. So the system directory is what you get back here.
Yep.
So what they're going to do is search for the first / or / and cut that off. So that's what this does here. Last index of the /. And then they're going to append to that Microsoft.NET framework version something. So that's basically going Microsoft.NET framework, and then they're going to go version whatever they want. So, for example, version 1.1.4322. Now, the big problem is that a lot of people have been doing, we've actually seen this happen in a big real-world app, is that they then take that version string and they go, okay, I got to now take 8 and add it to the path, 8 characters.
Yep.
And the reason for that is they go, oh, okay, so the way the build numbers are formatted are like 1.1.4322.
Yep.
So that's actually 8 characters. Append it to the path, and then now we have the path, and then they go try to find DLLs like MS Core Lib. The big problem with that, though, is for Widby, we actually changed the build numbers to be 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. So Widby build would be something like 2.0.50509 or 50215. So what ends up happening is that they end up getting the wrong path, and then their app is broken at install point.
Yeah.
So this is one of the things that we see customers do all the time, which, like, taking dependencies on things like the file structure of where we dump files, or like the number of files, or the actual, like, they take dependencies on things that aren't part of, like, sort of the public contract, and it's something that we don't want them to do. So that's one example of a break where your app now all of a sudden behaves differently just because you're running on a different runtime.
So this is similar to what we talked about with Shrupa, where there are things that we know are going to change, and there are things that we document and say, here's what you can use. And there are APIs to find the framework version that you can use. But if we find your application is actually broken by something you shouldn't have been relying on or wasn't documented to be something you could rely on, if we know an application is breaking, we'll do everything we can in our power to make sure that that application keeps working. But in this case, we've done a lot more builds. There are a lot more builds in Widby than there were in Everett, and we got more than 9,000 builds, if you believe that or not.
Yeah.
And we had to add an extra digit. So that's the type of thing we really can't do anything about that. So we're going to have to ship Widby like this. And we've already contacted the vendor, and they know about the problem. They're going to fix it. But this is the type of thing, unless you test it, there's no way we can know that this is the type of behavior that someone's depending on.
Yep.
So.
Okay, so we have another demo. This is just a little simple web page. And what it does is it calls math.ceiling on whatever you enter in this one text box. So enter this. When I hit calculate, it just calls math.ceiling. So you can play this a bit. So it calls math.ceiling. I'm going to take the exact same app, and again on my handy dandy. So this is on Everett. So this is the expected behavior on V11 where the app is built.
Yep.
I'm now going to take the same thing. Let's move that out of the way. And I'm going to run it now on my would-be box. I hit calculate. Uh-oh. What is going on? Nothing seems to work.
Yep.
So I'll show you the code for this one. And I guess we're going to use Notepad. All this thing does is, if you look over here, we get the text from the first text box, parse it into a double, and basically we're calling math.ceiling on that double return from the first text box and putting it, setting it to the text of the second text box. So that's pretty much it. So why is this broken? So now let's do some investigation. So let's take a look at how the actual math.ceiling function looked in Everett. So to do that, we can just open it up with ILDASM.
I think I'm going to come back and get some lessons on the command prompt from you. You're one of the fastest Microsoft employees I've seen working with a command.
Okay, so system.math. Now let's see, ceiling. So here we go. So it takes a float.
Okay.
So now let's go look at what happened to it in Woodbey. So framework SDK.
Can you explain a little bit more about what ILDASM does?
Sure. So ILDASM is a tool that ships with the SDK. It stands for IL disassembler. It basically shows you what metadata is contained inside an assembly when you use it in GUI form, like in this format. But you can also use it to spit out the actual IL, and you can use the sort of opposite tool called ILASM, which is IL assembler, to sort of recompile your IL into a PE.
PE is an executable?
Yeah. Okay, so we're going to look at... Now, let's see. So, system.math. Oops, passed it. Ceiling. So, now we have two versions of ceiling. One that takes float and one that takes a decimal.
Got it.
So what's going on here? So this is sort of one of those interesting cases where it's both potentially a design time breaking change. In other words, if I took that same code and say this wasn't an ASP.NET app and I recompiled it, I'd get a compile time error saying this would be an ambiguous reference. Because in Everett, it knows to resolve to that one ceiling method, but now there's an extra overload added. And so because what I'm passing in is not one of the exact parameters, like it's not a float or not exactly a decimal, it doesn't know what to resolve it to, so you get an ambiguous reference error. The interesting thing about ASP.NET, though, is that ASP.NET pages can be compiled at runtime. So I have this code that worked fine, and then I'm not planning to recompile it, but because it's an ASP.NET page, the moment I run it on a Woodbey machine, it gets compiled at runtime, and hey, it doesn't work, and it just fails.
So this is when you configure the ASP.NET page to actually run on 2.0.
Right.
Installing 2.0 is not going to cause you to run into this type of problem.
Right. So in this particular example, the reason why it's failing is that this machine only has 2.0. Okay. ASP.NET should by default run side by side unless you configure it to run against 2.0.
Very cool.
So those are simple demos. The way you can help us with this really is to let us know about your apps. So the biggest problem with app compat testing has always been getting the right apps to test. I mean, in V1.1, I guess, originally between V1.0 and V1.1, there weren't all that many apps out there. And sort of the space has grown tremendously, and especially between V1.1 and V2.0, like there are thousands of apps now out there. The big problem with these apps, though, is that most of them aren't really sort of things you can walk into stores and buy. I mean, I can't walk into my local whatever store, like computer store, and just grab these apps. A lot of them are pretty much large kind of business apps that people are using as corporations. And the thing about that is that we don't have the infrastructure here to actually go about and test these. the other thing is we also don't know what to test. Even if we did have the infrastructure, which we can set up fairly complex apps. I mean, what to test now? I mean, the people who wrote the apps know how best to test them. So what we're really encouraging is for people to take this by the horns and like, okay, my app should be tested against the next version of the .NET framework.
So, like, if somebody wrote an internet component for the Boeing internet,
right?
You know, an expense report generator or something
Right.
like that. Obviously, we don't.
Obviously, I wouldn't know. I mean, how am I going to test this? Are you going to give me access to the Boeing database? Like, what's going to happen? It's very difficult for us to test.
Yeah.
So the idea is, hey, we'll help you test it. I mean, we'll tell you what you need to do. We'll provide resources to you. But make sure, go test it yourself, and we're here to help, right? So that's the idea.
So Rob has a great document that has been posted on MSDN that we'll give you guys links to next to the video that goes through all the details on how to test an application. So it'll show you how to run through the 8 scenarios, or if you don't have a 64-bit machine, the 4 scenarios that Shrupa talked about earlier.
Okay.
So it'll be really easy for you to go through and see which ones are important to your application and make sure they work. And then exactly how to let us know if they don't work,
Very
so
cool.
that we can take steps.
So
you have a cool job here, right? You get to see all these .NET.
I have the sweetest job, pretty much. In the so basically, I sit here.
This
and
is
then
just a way to score free software, right?
people send me free stuff, and so people send me thousands and thousands of dollars worth of this cool stuff, and basically I come in, and we always need a baseline first, so that's basically play with it first, and then after that is okay, fine. Now let's see if the behavior is the same on Whitby kind of thing.
The best was
All right, what's your favorite .NET app that you've seen so far?
Oh, I have some cool ones. Can I say their names?
Go for it.
So for example, we have a managed version of Quake 2.NET.
Ooh.
So that's fun.
That one's good fun.
That's good fun to test. Yeah.
Another one is this game called Arena Wars. I think you've blogged about this one a couple times. It's the first managed C# game that we've seen. It's a really cool app. We had fun testing that one.
Does that fly with your boss when you're playing Quake and
so
you're like, hey, I'm testing?
So we stress tested the network play on that game like you would not believe.
So the funniest thing is so I'm playing these managed games and people come in and that guy's never working. He's always playing these games. What's he doing? So yeah, it's pretty fun. Yeah, a lot of cool things are out there. It's funny.
We can do a lot of cool tricks on getting even these large line of business applications in-house. For example, we have a lot of people that send us VPC images. We don't know how to set up these large ASP.NET apps and the SQL servers and whatever else they connect to, but the people who wrote them do.
Yeah.
So they can set up a VPC image, a virtual PC image, and send it to us, and that way we can just test that and we don't have to worry about the setup. And usually they also send us instructions or even sometimes their unit tests.
That's why you have these noisy machines in here. Yeah?
That's why, if you look in here, he's got about 20 boxes in this room.
It's a bit of an oven. Yeah, I'm a bit embarrassed that it's so messy.
You should see my office.
The real problem for those apps is we can't find your internal line of business app, so that's why we're encouraging you to let us know and to contact us, and we'll see what works best for your application.
Very cool.
So one last thing.
Yep.
We've created a slide for you, a single slide deck.
Cool. We'll put this up on the on the video.
Okay, cool.
Well, thanks for spending some time with us.
All right.
So
Thanks for coming
that's
by.
it.
Yeah.
Excellent. Thank you for a tour and telling us more about Apple.
We hope to hear from you guys.
Thanks.